Okay, good afternoon, everyone. I want to welcome you to another statistical consulting class. And of course, the past recordings have it's already on YouTube. And if you want to go into YouTube, of course, if you put my name, you're actually going to see the videos. Make sure you you review the one on this course because I indicated the start code and the topic. The other time we started observational study, and of course um I told you we're also going to use the same material today. So today I'm going to go over this material. I'm also going to go over another material. I've already uploaded that second material, that we call the measure of association. So, but right now I want us to focus on type of observational studies. Of course, before now, I introduce you to research design, okay, the kind of, blueprints that guide the way we conduct research study, okay, how to choose appropriate data set, how to analyze, and how to get a result that will be valid, reliable, and that can be generalized. Okay. And of course, I remember I said we got two type of studies, okay, for you to consider designing your research. You need to be able to know the type of studies available. I remember I started with experimental study, and last Wednesday I walked you through observational study. And I remember I also gave some kind of criteria that one can use to conclude causation on observation from observational studies. But right now, the story continue. I want to walk you through type of observational studies we have in case you go in that direction. Okay, so you're welcome to type of observational studies that we have. Um, okay, so let's take a look at this. Okay, you know, the type of observational study that we have, it depends on you how you sample. Of course, we know that uh, you using observational study, you actually just want to observe. Okay, you want to observe, probably you want to conduct a survey to get information about what has happened. Okay, and of course, sample is going to be involved. Taking sample will be involved from the target population. You've identified a population of interest and you choose a sample. So the way you choose your sample matter. So for me to be able to discuss the type of observational studies, I have to put into consideration uh, the way that I sample. Now I need you to take a look at number one that I call categorize observational study based on when the response happen. When the response happen is when the outcome happen. So what outcome do we want? In clinical study, it may be outcome that has to do with development of disease. Okay? That's an outcome. So depending on what the researcher is looking for. So if you want to base it on outcome, if you want to base your sampling on outcome, okay, like I want to sample based on outcome. So what I'm actually going to do, there will be two type of studies that can be conducted in that regard. It's either I want to look backward or I want to look forward. Okay? Depending on whether I want to look backward or I want to look forward. Looking backward is retrospective. So looking backward is just for us to observe, the outcome from past record. Okay? If you go some website, they have a record of data that you can actually uh, you know, take a look at. So that was why I said a potential issue with that when using interview to gather data on past experience, there's possibility that we should have a recall bias. Okay, recall bias like the ability to recall by the respondents. Okay, you know there are some of them that may not be able to, and we don't want a situation where the kind of information we're going to be getting is not accurate. What is the essence of analyzing data set that is not accurate? It's a waste of time. Okay? So retrospective is looking backward using what I call historical data or going to record. Okay? And you observe the outcome. You're observing the outcome like, oh, those who have actually developed the disease. But prospective now is waiting for outcome to happen. Waiting for outcome to happen actually means maybe you conduct a survey and you ask question about exposure. What do I mean by exposure? Or maybe probably you are investigating the effect of smoking on lung cancer, okay, on the lung disease. Let me just say on lung disease, okay. And right now, some people they're already smoking. You know those are smoking. You know those that are not. You now want to wait, okay, over time to see whether any of the group will develop the disease. So it's like looking forward. Okay. That's what we call prospective. Okay. Now, uh, if you take a look at, so what I'm trying to say is that the type of observational study, it could be retrospective, where you look backward. It could be prospective, when you look forward. Now, another category of type of studies in observational, uh, you know, in observation is when we consider, when we consider the way we sample, the way the sample was taken, okay? The way the sample was taken actually matter. So if we want to put into consideration the way the sample was taken, we're actually going to consider what we call cohort, case control study and cross-sectional study. And of course, I'm actually going to explain that one after the other. Now, if I want to do my sampling with respect to outcome, what is the meaning? Oh, respect to outcome, which means I just deliberately want to go into the field and sample those who have the disease and those who do not have. That is, I'm sampling with respect to outcome. The outcome has already occurred. Does that make sense? And if I sample with respect to outcome, it's going to be case study. Okay? That's what we call case study. Sampling with respect to outcome. Okay? Deliberately go into the field, select those who have developed the disease and those who have not. And the only thing you're going to be looking for, you now want to retrace. You want to see if you can attribute that development to what those participants have involved themselves in. Okay. Now, if you're doing that, but if you go into the population and you only base your sample on those who are currently exposed, but they do not have the disease already, but they are currently exposed. Maybe right now they are smoking and some are not smoking. That means they are currently exposed. Okay, so if they are currently exposed, that would be a cohort study. It will be cohort study like you're gonna be monitoring them, putting them in a cohort and wait whether there's gonna be development of disease because they are currently exposed. Does that make sense? But in a situation where you sampling and you did not put into consideration either. You don't put into consideration the outcome. You don't put into consideration, the exposure. Then definitely the kind of study you can do in that regard is cross-sectional. Cross-sectional is more or less, I'm going to go into the population, okay? I'll be blinded. I'll just choose sample size randomly. I don't know whether they have the disease. I don't know whether they are exposed. But from the sample size, from the information I'm going to get from them, then I will be able to reclassify. That's what I mean. Now I'm going to show you some example now. Okay. I'm going to show you some example now. Okay. I want to start with a case control study. Now, but whether you want to talk about the case control study or you want to talk about um, the prospective or retrospective or what have you, okay, you need to first be able to identify what is your risk factor, that is, what is the exposure and what is the outcome. And that's what, so in the example that I want to cite here now, okay, in the example, I'm trying to look at the effect of smoking on the lung disease, particularly lung cancer. So I need to be able to identify, the exposure is going to be smoking or not. Okay, smoking or not, then the outcome is going to be the disease itself. I need to first recognize that. Now, if I want to conduct a case control study, don't forget, if I want to conduct a case control study, okay, I'm actually going to be sampling, okay, with regard to outcome. It has happened. Case control, that's what I call case. It has already happened. So right now, I'm going to choose 50, okay? These 50 that I choose, okay, some of them have the disease, some of them do not have the disease. I'm not going to choose everybody that have in my sample is not going to be the sample of everyone that have the disease. No, don't forget the other time we talk about the significance of control. Okay, so we're actually going to choose those, which means right now you can see I put the cases now 25 have lung cancer and 25 without, making 50. So which means if I want to go into the population, I know I want to choose 50, and I know that the 50 that I want to choose, I will be targeting those who have the disease and those who do not have. I'm not interested in exposure. I'm only interested in those who have the disease. Okay? That is what leads to that. Now, I give them questionnaire. Okay? And maybe at the end of the day, I realize that if you take a look at this right now, I realize that the 25, out of the 25 that have the disease, okay, 24 of them smoke. And it's only one that is not smoking. And out of 25 that do not have the disease, 15 smoke and 10 did not smoke. Okay, this I later find out about exposure, from study. Okay, I later find out about exposure. My sampling initially did not focus on exposure. My study initially focused on the disease, those who have the disease and those who do not have the disease. Okay, that being said, I want to go into cohorts. In a cohort study, I'm actually going to sample with regard to exposure. I'm not interested in those who have the disease. Okay? I'm only interested in exposure, those who are currently exposed. I want to choose 50. I want to take a sample of 50 from a target population in such a way that the 50, 25 will be those who are, who actually smoke, and 25, those who do not smoke. Okay? Now, after that, okay, that is what you see right here. And at the end of the day, maybe I wait or not. Okay? Later, I realize out of 25 that smoke, okay, only 2 have the disease. Okay? If you take a look at what I have, okay, so no long cancer for that or that. So I later find out that. Now, in a cross-sectional, don't forget, in a cross-sectional, my sampling, taking a sample from the population with without regard to exposure and outcome. I just pick on anybody. I don't have outcome I don't want to sample them based on outcome. I don't want to sample them based on exposure. Now I only choose 50. It was later that I found out what you see in the table here. Okay. It was later that I actually find out. Okay. Now, when you take a look at what I have now, I think I've just given you an idea on how the type of observational studies, okay, the way it's going to play out. But there's something I want to say. Why, when we get to this junction, okay, what are we going to do? We already have our data set in tabular presentation. Now, our intention is to figure out the measure of association. Because the nature of the variable that I'm working with is categorical. If you take a look at exposure is categorical. It has 2 levels, okay? And not only that, the outcome is categorical, it has 2 levels, okay? Now, what I'm going to be thinking of is how do we, you know, test association when categorical variables are involved. So whatever we're going to be doing here now is going to be analysis of categorical variables. Okay. If the variables are quantitative, I'm seeking to get association or relationship, I'm actually going to pursue that in a correlation way. But right now, it's not going to be correlation at all. Okay. And that is why I attach the second material. The second material is a measure of association. Okay. So, but I need you to take a look at this. There's an interesting picture here, which is going to make you to understand what we mean by different studies, observational studies, or whether case control or cohort and so on like that. And the kind of association measure that you can actually use. Okay, now I need you to pay attention now. Okay, now if you take a look at this, okay, if you take a look at that, okay, right now, okay, I know, I'm talking about case control where the sampling is done with respect to those who have the disease, okay, the outcome. So right now, the dots, if this guy, those who have the disease and those who do not have. But what question do we want to answer? We want to answer question about exposure. What could lead to them having the disease or not having the disease? Does that make sense? And that's why I put a question mark. We put a question mark. If we want to answer that question, those who actually have the disease, then it means we actually need to look backward. We want to retrace what what is the factor responsible. And let me tell you this: if I want to have a measure of association, okay, if I want to have a measure of association, okay, we we need to decide using odds ratio or relative risk. So odds ratio and relative risk are very useful statistical ways of assessing relationship between two categorical variables, particularly when exposure and outcome, are involved. Now, when I'm dealing with the court, when I have a case control study, okay, uh, it is we can actually use odd ratio in figuring out association between the two. Using relative risk may not really do a great job. Now that's why you cannot obtain an RRR for this. It doesn't make sense because the researcher will be the one that will set prevalence in this case. And don't forget, this is particularly if you want to use this for a rare disease. Maybe you want to, maybe if the outcome is not lung cancer, if the outcome is heart attack, it took a long time for heart attack to occur. It's a rare, where somebody may wait forever. Okay? So I just wanted to take note of that. Now, another thing in the image, if you take a look at this guy now, okay, the prospective cohorts, okay, right now, people are exposed. And that is why you see this guy. The black dots, some are exposed, like those who are currently smoking, in the case of looking at the effect of smoking on lung cancer, and some are not. And you want to answer a question, you want to wait to see if they will develop the disease. Okay. I just want you to, take a look at that. So that was why you see a question mark on the disease. Okay. Now we have, and the measure that can be used, measure of association, uh, the both relative risk and odd ratio can be used in this regard. Okay. Now, if you go for the other one, which we call uh, retrospective cohorts. Okay. If you look at the retrospective cohort, okay, we have exposure, but you will see that the two cohorts, one prospective, the other one retrospective, okay, even though in the two, we actually want to figure how the development of the disease will already have exposure. It depends. In some, we can look backward, okay? And in another one, we're actually going to wait. Does that make sense? We're going to wait. Okay. Now, I think I put some, okay, on the cross-sectional study. Like I said, the cross-sectional study that doesn't put into consideration the outcome and exposure, okay, is relatively quick, not expensive, okay, and could be used to estimate the prevalence of a disease. Like, what is the probability of having a disease in a population? That's what we call prevalence of a disease. But it's not useful for identify cause effect. Maybe What you are only interested is linkage, association, but you are not interested in whether one causes the other. You know, association can exist, okay, and that association does not imply causation, okay. Now, for the case control study, you know, in the case control study, don't forget, you sample with respect to those who already have the disease, okay. Now, we said it can obtain an adequate number of cases for studies of rare disease, economical and good to compare to prospective studies, and actually may provide, you know, evidence for possible cause and effect. Okay. So I just wanted to take note of all of that. And for the court, okay, the court, okay, we are right now, some people, the participants are exposed. You're waiting for disease to happen, outcome to happen, okay? It's actually going to provide us cause and effect, but the issue is that it's going to be time consuming. I may wait forever. You know, there are some diseases that are rare, like heart attack. So if I wait forever, apart from consuming time, it's also going to, it's expensive. So I wanted to, and there could be potential for high dropout, like those participants in your cohort, some of them may relocate. Some of them they may not even be interested again. Okay? So they're not suitable for real outcome. I told you the real outcome is occurrence of maybe like heart attack. So in case you need more information, okay? Now take a guess. What type of study finally provided conclusive evidence that smoking is a risk factor for lung cancer? Smoking causes lung cancer. Okay. So if you want to take a guess, you need to first analyze, you know, to be able to analyze your data set. And with the kind of information you have right now, you can actually think about it. I'm going to stop my share right now. And is there any question before I think I'm going to go into another material that I have. Now the materials I've already uploaded that. I've already uploaded the material. I think I uploaded it some minutes ago. I'm actually going to share the material right now. Okay, so I'm sharing the material right now called a measure of association. So the measure of association, here we need a statistical methodology. We want to figure out relationship between exposure and outcome. So in the outline here, at times we may have more than two groups. You know, I'll be talking about two groups like control and the treatment group. It could be more than two groups. So I'm actually going to walk you through multiple exposure groups. We could have more than two exposure groups. Then I'm going to walk you through how do we compute the relative risk, how do we compute odds ratio, okay? The risk differences is not it's not important to me for now. Take a look at this. This is a computation. I'm actually having a multiple reference group right now. You know, the study here is I want to look at the effect of magnetic field exposure to the risk of us having leukemia. Okay, to the risk of having leukemia. And the magnetic field exposure has three levels, not just two levels, three levels. Okay, you could be exposed to high, medium, or low. But here I'm going to use low. We're going to use low as a reference group. Okay, as a reference, as a control. Okay, it's the smallest in the scale level. Now, you can see what I have. Okay, there are 674 of those who have been exposed to to high magnetic field. Okay, 1,469 for medium and 67,424 for low. Okay, and if you take a look at that, let's see how many have leukemia, how many do not have the leukemia. That's what you can see. So I want to actually, if you look at what I said some cohort studies and clinical trial compare the risk of disease or other outcome among three or more groups. So what I want to do here now, if I want to find the cumulative incidence, okay, cumulative incidence of disease based on what I was exposed into, okay? So out of 674, okay, we're interested in those who have leukemia, which is going to be 30 divided by 674. That will give you 0.0445. We did the same for medium. We did the same for low. And if I have this right now, it's just a simple computation. Then how do I interpret this? And I'm gonna show you how we interpret this. Okay. Now, if you take a look at what I show, this guy is the one that I got for here uh here. You see that 0.0, that is for the lowest exposure, the one we're going to use for as a reference. Okay. Now, if you want to interpret that, that is if you multiply by, we normally you can interpret by 1,000. I'm going to say 33.6 per 1,000 over the period that we have observed. We also interpret for the medium one, you interpret for the the ISL group exposure as well. Now, if you now want to obtain the risk ratio, the risk ratio that you want to do now is to compare one group of exposure with another group of exposure. And what I'm doing now, okay, if you take a look at this, I'm going to be comparing high group exposure to low and medium group exposure to low, because the low is a reference group. Does that make sense? And that's exactly what I'm gonna compute the relative risk for that. Okay, you take a look at this one, and you take a look at this one. Okay, I'm actually using, this guy here. This guy is going to be in the denominator, and each of this is going to be in the numerator. So that's what you see here. And at the end of the day, okay, if you how do I interpret 1.23? When the ratio is the same, okay, that's 50-50, right? But right now, it is greater. Don't forget you are comparing the medium to low. Okay, when you have a value greater than 1, that means the risk is more in the numerator. So right now, the risk ratio for medium exposure compared to low, okay, don't forget the low is a reference, is 1.23, and the one for that is that. This is interpretation. Compared to children exposed to low magnetic field level, those exposed to the medium level have 1.23 times the risk of leukemia. Oh, 1.23. Okay, 1.23, that is 23%. That's what I mean. 1.23% increase in risks. Okay, and those exposed to high, 33% increase in risks. Does that make sense? Okay, so that is the interpretation. Now, if I go into quotes now, okay, so from what we have done, I think I've explained all of that, before. I just want to now let's now go into the a case control design. Okay, now if you take a look at this population, okay, Plymouth county population is 502,000. Okay, 502,000. Maybe we will actually want to study the incidence of disease. This Plymouth County is in state of Massachusetts. Okay, so and you can see individuals make a state, right? Make a county. Look at that. Some will have the disease, some do not have the disease. Okay, now take a look at this. Okay, you know, let's say I actually sampled one thousand seven, 1007 here, those who have exposed, okay, and not exposed is that, okay, and because I'm conducting a case control, okay, probably focusing on disease, okay, and along the line, every I have other stuff. I'm still going to have a table, whether case control, whether what have you, any type of observational study, we're actually going to have a contingency table where the level of exposure is being cross-tabulated with the level of outcome. Now, if you take a look at what I have right now, okay, if you look at what I have right now, I can actually do the same what I did the other time, okay? If I want to look at the incidence in the exposed individual, 7 over 1,000, you can see 7 divided by the total, and 6 divided by that, okay? And that's why you have that. Since you can see right now, and that was why you actually have what you have is 0.70%, okay? 0.70% in the non-exposed individual, okay? Well, and with that, then the other one is going to be. So if you have any not exposed to be that, and I'm sorry, in the exposed to be that, and in the non-exposed to be that, in the exposed to be this, right? In the non-exposed to be this, then I'm going to look at the ratio of the two. Now, looking at the ratio of the two, this is going to, oh my God, that is far from one. 6.5. That is far from one. So if you take a look at that, and that was why we said, suggesting that those who have the risk factor, that is, are 6.5 times the risk of getting the disease compared to those without the risk factor, we suggest a strong association. You remember the other time, one of the E criteria for causality, okay, is having a strong association. Does that make sense? Even though temporality is the strongest. Okay, so I think I put several examples. And let me tell you this. At times, we may not know the total population of those who are exposed and total population of those who are not exposed. I'm putting that as unknown. Okay, the total population of those who are maybe unknown. Okay, but we know the total population of those who have the disease and those who do not have the disease. Okay, we can still go ahead and, but at the end of the day, you actually see that it's still going to give us 6.53 that we got the other time. Okay, here this is what we call the odd ratio, whichever way we want to go. So in this kind of you're going to, since the total population is not available, we're not going to make use of that. We're going to compute that a different way. You see that we didn't make use of total. That's why the fact we didn't make use of total. We still have 6.53, just like the one we got here when we make use of total. We still have 6.5 approximately. Okay, so let me see if there's any other thing. And if you have total, you go the same way. Okay, this guy here talk about odd ratio, and that guy talk about relative risk. Okay, so that is that. Um, I think I don't want to go too much. I don't want to go. I think I'm gonna stop. I'm gonna stop. here. Is there any question? Is there any question? I think I've already shared my talk. I've already shared the information about the venue. It's going to take place on Wednesday, I think 150 Ford Hall. So 11. Okay. So for those of you, so you are invited to my talk next Wednesday, February 5. I've already shared the information on announcement section of the canvas. Okay, it's another weekend. Make sure you all stay safe and have a lovely day. Bye for now, everyone.